Assalamualaikum warahmatullahi wabarakatuh. My name is Amar Baihaqi. I am from group 2. Group 2 pula. Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh. My name is Amar Baihaqi. I am from group 4. These are my teammates. First is Muhamad Syahir bin Mazlan and Nur Aini binti Zulkarnain. Okay, next for the introduction, I will pass to Nur Aini.
Assalamualaikum. So today I will be presenting on the introduction for this project. So I will be talking on regarding direct online starter, forward reverse starter, and also PLC. So first I will be talking about doll, which is direct online starter. So a direct starter is a motor starter which consists a main contactor and a relay and some safety features such as MCB, main circuit breaker. And mostly doll uses starter winding connected directly to the main, therefore it's usually used for a very small engine. So for doll, for this project we use like 2 push button just for stop button and start button, and then 2 lamp, which is green lamp and red lamp. So next will be forward reverse starter. So a forward reverse starter is a forward reverse magnetic which construct from a 2 regular contactor that was installed to prevent both coil from pulling in simultaneously, and this is what we call interlock. So when we push for a forward reverse starter, we use 2 push button green and 1 push button red. So those two, 1 push button green was for forward and another push button is for reverse. So the interlock will occur when how it works is when we push the forward push button, supposedly the motor will run clockwise, and then when we try to press the reverse push button, it will not change until the stop button is pressed. Therefore, we need to press the stop button first, then we can press on the reverse push button. So interlock occurs, as we can see, is when each other doesn't interrupt each other when either one was pressed. Okay, so next is PLC. So the PLC is a programmable logic control that collect and process data from connected sensor or input device and begins output according to pre-programmed specification. So for this part, PLC, it's supposedly we program the PLC to work as a direct online starter, forward reverse starter, and also the third one is a forward reverse starter, including a timer. That's all for introduction. Now I will be talking about the objective of this project. So the integrated design project IDP provide a student with hands-on experience in design development, construction, prototyping, testing and validation, as well as deep understanding and project management skill. A group of 3 or more students each need to complete the IDP project. Therefore, for this project, the student must build according to the required task, and the project must include relay, timer, and counter instruction by using a normal latching or any sort of ladder logic that can complete the task. That's all. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Mazlan, and I will present about case study. First of all, case study 1 is direct online starter motor. Direct online starter motor is a simple motor which is only have a 2 push button. One is start and another one is stop button. And we only use 1 contactor and 1 MCB, which is miniature circuit breaker. To connect 3-phase circuit, we only need 3 wire, red, yellow, blue. For phase red, phase blue and phase yellow. After we connect our wire from supply to MCCB, and connect to contactor RST and UBW, and connect to motor. And the operation is when we press start button, the motor will running, and after we press the stop button, motor will stop. And case study the motor is forward reverse starter motor. Forward reverse starter motor have two different rotation motor, which is forward and reverse. So they need a three push button, forward button, and reverse button, and stop button. First of all, we need two contactor to make our latching. Second, we only use one MCB. Okay, to connect the 3-phase wire is same as our direct online motor starter. Then operation of this motor starter, and when we press forward button, motor will rotating forward. And when we press our reverse button, nothing happen because we use electrical interlock. And to need motor to forward reverse, we need to press stop button first. And after motor stop rotating forward, we press the reverse button next, and motor will rotating reverse. And to continue this step, we need to press stop button again. And the third one is dual direct online starter motor with PLC. First of all, the connection of direct online starter motor is the same with direct online starter motor with PLC, but the input and the output we use a PLC trainer. First of all, we need to build our ladder diagram in CX programmer, and the address for start button is 0.00 and stop button 0.01. The output for motor running is 100 and 00. The operation is simple, but our push button not on the board but in a plate set button trainer. Okay, the operation is safe. When we press the start button, motor will start running, and we press the stop button and motor will stop. And for the reverse starter motor with timer, first of all, when we press stop button, okay, forward reverse starter with timer. Okay, first we build a ladder diagram for these three address, which is reverse, forward, and stop. For reverse address, we use 0.07, for forward 0.05, and the stop button is 0.03. And the output for motor rotating forward 104, and motor rotating reverse is 105. First, before we put the trainer, we must decide the timer that we put before motor start rotating. For forward, we use 6 seconds, and the reverse we use 3 seconds. And the operation is when we press start button reverse, forward, motor will timer will start count until 6 seconds, and motor will start running. And we press the stop button, then we press reverse button, and we wait 3 seconds, and motor will start running. And they will continue until we press the stop button. And forward reverse without timer, each is the same function as forward reverse without PLC. So the difference is our reverse, forward, and stop button, but we use on set trainer, button set trainer. So we use address the same as our forward reverse with timer. The address is forward 0.05, reverse 0.07, and stop 0.03. And the forward output, forward 104, reverse output 105. But this motor starter not use timer, so we will press forward button, it will automatically start running, and we push stop button, then we press reverse button, and motor will start running, rotating reverse. Then we press stop button to continue another rotation. Alright, thank you. Okay guys, for experimental setup, we operate actually first we connect circuit breaker with our contactor, and then output of this connector we connect with push button, and this is experimental setup. Then below is control circuit. The equipment in control circuit is circuit breaker, contactor, and push button. And then is motor circuit. First we include our motor, and we connect our wire with the contactor, and before that we connect contactor with circuit breaker and supply 3-phase. Then instrument setup with PLC, we put extra equipment which is PLC trainer and push button set, and the connection is same as we are PLC, but we don't use push button at panel, so we use push button and a PLC trainer, and it is connection which is power supply, push button, flame indicator, PLC trainer, relay, motor, contactor, and circuit breaker. Alright.
Why connect to three-phase AC motor? Before that, I will explain for my result. Okay, what we look here, this is a Amar trainer. This is a push button, lamp indicator, timer, motor, and contactor. Okay. First of all, this is how it work is when we set contactor 1 to when we push the push button 1 stand for forward, push button 2 for reverse, and push button 3 for the reset. Okay, when we put a relay at here, at a trainer, and we connect at relay at here at the board, and lamp indicator will connect to contactor and connect to lamp indicator. The contactor one to set to manage the input output at the motor, at the circuit breaker, and from the lamp also. So we set here when we set here when the push button, we press push button 1, the green lamp indicator will glow. When in 10 seconds it will glow, in 10 seconds it will be closed. We set because we set at the timer at the PLC trainer, when 10 seconds it will be closed, and the red will be glow. So what we AC motor will on when the timer on, and the motor will off when the AC motor off. So what we leave here, why we connect to three-phase AC motor, to show the result, what we program this project.
Okay, so for my part, I will be presenting on discussion and conclusion of this project. So first of all, for discussion, I will be presenting and explaining on why the student preferred control system, and number 2 is challenges that occurs while constructing the circuit. So first of all, the student preferred control system due to this project exposure on making the student construct and wiring the circuit on their own, which makes it not just fun and enjoying, but the student were also able to understand the circuit much better, and at the same time they were able to polish their hands-on skills. And next, other than that, the project are also combining PLC and electrical power circuit, which the interesting part is the student need to modify the circuit, and when before inserting the PLC into the hardware. Therefore, the students are able to see on their own how the PLC can be operated the same way as electrical power system circuit function, but in a much more internally, means that the PLC work as the control system. And next, I will be explaining on the challenges that occurs while constructing our circuit. And first of all, the most challenging is the wrong connection when we are constructing the circuit, and how we solve it is by rewiring, by asking other groups on how they construct their circuit and how they manage to make their circuit to work, and we ask for their advice. And then we also double check our connection. Sometimes we ask other groups to troubleshoot our circuit, and this is during the constructing the circuit. And then the next problem that occurs are loose connection, and this the loose connection part happens during testing, when we are trying to test the circuit with the motor. So during this for this problem, it occurs when we are testing forward reverse connection at motor, and then we realize that when we press the forward button, the lamp doesn't turn on. So after we turn off the supply and then we check back our connection, then we realize the connection are loose. So how we troubleshoot it is by tape the wire and then also tighten the screw that are needed using a screwdriver. And then another part was loose parts. Loose part always a problem for us, for our group, because for the push, especially for the push button, the screw always loose and always comes off out of the hardware, out of the part. So we either tighten the screw, and sometimes if we just another way, a much more simpler way, we just replace it with a new part. So that's all for our discussion. Next, I will be explaining on the last part of this slide, which is the conclusion that we gain from this project. And first of all, the best part was the students are able to wire the circuit on our own, develop the circuit, which is the direct online starter and forward reverse starter, and that has been a very, very great experience for all of us. And we have a good understanding on how the circuit was constructed, and then we understand a lot more on how it operates, and then we were able to see how during the testing and how it works as a main circuit itself, and also and after it was connected to the motor. And then this project also combining the PLC with the electrical power circuit. Therefore, we were able to have a very good understanding regarding the PLC itself, on how we can modify the PLC ladder diagram to work the same way as the direct online starter hardware and the forward reverse hardware. And we also and for my group especially, we are using we doesn't it, our group doesn't use like other group which is using the PLC and the relay. We actually use CP1E trainer, relay, and also and a push button panel kit. Therefore, we were able to construct the circuit by combining like all those trainer kit and the panel with the hardware on the wooden board. And for me, that is like a very good experience where we were able to combine a trainer kit with a hardware electrical parts, and it's also a very good practice for a student to practice a problem solving, since those two doesn't come as one. It's a different part, different component, and also same goes for the wooden part, and then same goes for the trainer part. So we were able to combine both of that to work as a one project. It's a very good practice, and it's also preparing a student to face the real industrial exposure with a basic circuit construction. And that's all from our group. Thank you.